Hello students, today we will discuss about the reasoning patterns under artificial intelligence. Reasoning patterns in the context of artificial intelligence refer to the strategies or methods used by AI systems to draw conclusions, make decisions, or solve problems based on available information and knowledge. These patterns encompass various approaches to logical inference and problem solving that are fundamental to AI systems. Some of the common reasoning patterns which we will discuss now are deductive reasoning, inductive reasoning, probabilistic reasoning, and fuzzy logic reasoning. First, let us discuss about the deductive reasoning. This deductive reasoning involves deriving specific conclusions from some general principles or premises using logical rules of inference. In deductive reasoning, if the premises are true and the logical rules are valid, the conclusion must also be true. Please note that here must be true is very important. Deductive reasoning is used extensively in formal logic and theorem proving. In this regard, let us see an example of deductive reasoning. This example specifically is a formal logic example. So in premise 1, we see that if it rains, the ground becomes wet. In premise 2, we see that it is raining. So what is the conclusion? The ground is wet. Next we come to the inductive reasoning. Inductive reasoning involves generalizing from a specific observation or examples to form general principles, patterns, or hypotheses. Unlike deductive reasoning, inductive reasoning does not guarantee certainty. Instead, it aims to infer probable or likely conclusions based on observed patterns or trends. Inductive reasoning is commonly used in data analysis, machine learning, and scientific inference. A very good and classic example of inductive reasoning is that we can see three observations and we are going to draw a conclusion from that. Kindly keep in mind that here the conclusion is not certain or it is not always true, but it is a likely conclusion. So the first observation which we see here is that the sun rose in the east today. Next one says that the sun rose in the east yesterday. The third one says the sun has always risen in the east. What can we say from these three observations? We can conclude that the sun always rises in the east, but it is not guaranteed. If tomorrow the sun destroys or the earth destroys, we cannot guarantee that the sun will rise in the east. So I hope the difference between deductive and inductive reasoning is clear to you. Next we come to probabilistic reasoning. Probabilistic reasoning involves reasoning under uncertainty, where the truth of propositions or conclusions is uncertain or probabilistic. It employs the probability theory to represent and manipulate uncertain information, combining prior knowledge with observed evidence to compute the likelihood of different outcomes. Probabilistic reasoning is used in Bayesian networks, decision theory, and statistical inference. As you can see that I have given a diagram of a spam mail here. So we will discuss about spam mail as an example. Email services like Gmail use probabilistic reasoning to classify emails as spam or non-spam. In general, 20% of the emails received are spam. So this is a prior probability which generally occurs. We have an evidence that if an email contains words like lottery win or urgent money transfer, it is more likely to be a spam. So I hope it's clear that how this probabilistic reasoning helps to detect the spam emails from our email folder. Now the question arises, is always, if an email contains the word lottery win, is it always a spam? Not exactly. So even if the email, here we are just guessing, or we are finding a certain keyword by which the probability of that particular email to be a spam increases. But it does not guarantee that if an email contains the word lottery win, it is always a spam. That's why here it is very important to note the word likely spam. So it is more likely a spam. So if an email contains the words like lottery win or urgent money transfer, it is more likely a spam, but it does not guarantee that it is always a spam. Now we come to the last reasoning, that is fuzzy logic reasoning. The fuzzy word means the things that are not clear or are vague. Sometimes we cannot decide in real life that the given problem or statement is either true or false. At that time, this concept provides many values between true and false and gives the flexibility to fix the best solution of the problem. Fuzzy logic reasoning deals with reasoning in systems where truth values are represented as degrees of membership in fuzzy sets. It allows for the representation of vague or imprecise information and supports reasoning in domains where boundaries between categories are fuzzy or uncertain. Kindly note the word representation of vague or imprecise information here, as we will use these two words when studying the example. So it is used in various control systems, expert systems, etc. A very classic example of fuzzy logic reasoning is AC. So if the room is cold, set the fan speed to low. If the room is cool, set fan speed to medium low. If room is warm, set the fan speed to medium high. If the room is hot, we set the fan speed to high. So if the temperature is 30 degree, the AC doesn't just go full blast, but it adjusts itself slowly, adjusts the speed slowly based on how warm or how cold is the room. So I think the concept of fuzzy is clear to you now, where instead of telling, or instead of setting up a particular value, or instead of just keeping two values as on and off, we are keeping some uncertain values which are not clear or are vague. Now I hope the meaning of these two words are clear to you, that is representation of vague or imprecise information. So let us recap once more. What did we study just now? We studied reasoning patterns. Under reasoning patterns, we have studied four types, which are deductive reasoning, inductive reasoning, probabilistic reasoning, and at the end we studied about logical reasoning. Make sure to go through all the examples. Thank you, my dear students.